As I said that there are different types of the ANOVA, so now we are going to discuss those types, and we are starting from the simplest type of the ANOVA, which is known as one-way ANOVA, or the one-way analysis of variance. Now, one-way ANOVA allows the comparison of any number of samples in a single test, right? So we are performing a single test of ANOVA, and we can compare the mean values of any given number of samples in that single test. And we can do that test to see the effects of a single independent or nominal variable. So this is the point to consider here, that in case of one-way ANOVA, we are going to see the effects of only a single type of the independent or the nominal variable, or the predictor variable. And this ANOVA is also known as one-factor ANOVA, single-factor ANOVA, or single classification ANOVA. So these are different names for one-way ANOVA. So in one-way ANOVA, we have one measurement variable and one nominal variable. So in one-way ANOVA, we are going to have only one nominal variable. We are going to have different categories of that one nominal variable, and we are going to have one measurement variable against which we have multiple number of observations. So we have multiple observations of the measurement variable taken for each value or category of the nominal variable, right? So the type of the nominal variable is 1, and the number of categories of the nominal variable, they could be from 3 to many. And the measurement variable is only 1, and there are multiple observations of the same measurement variable in each category of the nominal variable. Now the other type of the ANOVA is a two-way ANOVA. So two-way ANOVA allows to see the effect of two conditions or two independent variables in a single comparison. Now in contrast to one-way ANOVA, in this ANOVA we have two nominal variables. We have two types of the nominal or the predictor variables, and we can see the effects of these two conditions in a single test. So we have one measurement variable and two nominal variables. This is also known as the two-factor ANOVA or the factorial ANOVA. For example, if we wish to compare the mean lengths of the silver carp, or if we want to compare the mean length of the 3 races of the species from 3 different islands, as we saw in the first slide. So in that case, if we want to see the effect of their sex as well, right? So we want to compare the mean values by sex and by island of origin. So in this case, we have two nominal variables, the island of origin and the sex. And if we want to see the effects of both of these conditions in a single test, again, we're talking about a single test. We're not talking about multiple comparisons, right? So we are allowed to do that. So in ANOVA, we have this flexibility that we can have more than one type of the nominal variable, and we can have more than 3 categories of each of these nominal variables. So that is why ANOVA is so widely used, that it has the flexibility of having any given number of the nominal variables and any given number of the categories in each of these nominal variables. And all of these effects, they can be assessed through a single analysis, through a single test. So we are not committing type 1 error in this case. And this also allows us to see the interaction effect. So this is not enough that we are going to see the individual effects of the two nominal variables, like we are seeing the differences in the mean values by their sex and by the island of origin at the same time. We can also see the interaction effect of these two different nominal variables, right? So this is an added advantage of using a single test, that you are not just calculating the effect of the two nominal variables on a single measurement variable, on a single outcome or the response variable. You are also seeing the interaction of these two nominal variables with each other, that what is their combined effect, what is their interactive effect on the measurement variable. So this is the two-way ANOVA. Then we have n-way ANOVA. We can have 3-way treatments, we can have 4-way treatments, and so on. So we can have any number of the nominal variables, any number of the treatments, and we can see their effects simultaneously in a single test, in a single ANOVA. So this is a multiple way ANOVA or the n-way ANOVA. For example, if you want to compare the heights of individuals, right? So we can simultaneously see the differences in the height of individuals by their location, by their gender, by their nutritional status, and by their ethnicity, all at the same time in a single test with a single level of significance, 0.05. Right? So this is n-way ANOVA. This could be 3-way ANOVA, this could be 4-way ANOVA, and so on, depending on the number of nominal variables that we are going to check. Now let's have a quick comparison of these three types of ANOVA. So what are their different names? The one-way ANOVA is also known as the one-factor ANOVA, single-factor ANOVA, single classification ANOVA. The two-way ANOVA is also known as two-factor ANOVA or the factorial ANOVA. The n-way ANOVA is also known as the multiple factor ANOVA or factorial ANOVA. So these are different names. And then the number of nominal or independent variables or factors or the predictor variables. So in one-way ANOVA we have only one, right? We have only one type of the nominal variable. It can have categories of 3 or more, but the type of the nominal variable is only one. In the two-way ANOVA, we have two types of the nominal variables, and their categories could be more than 3 in each of these nominal variables, but the types of the nominal variables are 2. And in case of n-way ANOVA, the types of the nominal variables are 3 or more. Then the number of categories of the nominal variables in one-way ANOVA, it could be 3 or more. In two-way ANOVA, for each of the nominal variables, it could be 3 or more. And in n-way ANOVA, for each of the nominal variables, it could be 3 or more. Then the interaction effect of the nominal variables, because we have only one nominal variable, so there is no point in checking the interaction because there is no other nominal variable. But in two-way ANOVA and the n-way ANOVA, we can have their interaction effect also calculated. So we can see the interaction effects of the nominal variables in two-way and n-way ANOVA. And then the number of measurement or the dependent or the response variable, this is only one. In all of these cases, this is only one. So this is a quick comparison of these three types of the ANOVA. Now let's see the difference between one-way and two-way ANOVA with examples. So the state of affairs is comparison of mean length of silver carps. So we have scenario 1 in which there is a comparison between mean length of silver carps from 3 ponds. So for that purpose we are going to use one-way ANOVA. So the nominal variable in this case is the location, which are ponds, and the number of categories of the nominal variables are 3. So there are 3 categories of location: pond 1, pond 2, and pond 3. And the measurement variable is only one, which is length. Now scenario number 2 is the comparison between mean length of female and male silver carps from 3 ponds. So in this case we are going to use two-way ANOVA. Why? Because we have 2 nominal variables. One nominal variable is their location, which are different ponds, and the other nominal variable is sex. So we have 3 categories of location: pond 1, pond 2, and pond 3, and we have 2 categories of sex: female and male. And the measurement variable is only one, which is length. So in this case we are going to see the mean difference between the length of the silver carps by their location and by their sex, and we can also see the interaction effect of these 2 variables. Then the next example is the comparison of dry weight of leaves. So the first scenario is comparison between dry weight of leaves from 4 fields. So we are going to apply one-way ANOVA. Why we cannot apply t-test here? Because there are more than 2 categories of the nominal variable. So here are 4 categories, and what is the nominal variable? It is location, which are different fields. So there are 4 categories of location: field 1, field 2, field 3, and field 4. And the measurement variable is only one, which is the dry weight of leaves. Then in the scenario 2, we have the comparison between dry weight of leaves from 4 fields in 2 seasons, right? And we are going to apply the two-way ANOVA because the number of nominal variables are 2, location and seasons. So there are 4 categories of location: field 1, field 2, field 3, and field 4. And there are 2 categories of seasons: fall and spring, for example. And the measurement variable is only one, which is the dry weight of leaves, right? So this is another way to compare the one-way ANOVA and the two-way ANOVA. See another example, which is the comparison of crop yield. So scenario 1 is comparison between crop yield from different types of fields with 3 different amounts of fertilizer. So in one-way ANOVA, the nominal variable is only 1, which is the amount of fertilizer, and the number of categories of the nominal variable are 3. The 3 categories of the amount of fertilizer: the amount of fertilizer, which is 50 kilograms per hectare, and those fields which have the amount of fertilizer as 100 kilograms per hectare and 200 kilograms per hectare. So these are 3 categories. So we are going to apply one-way ANOVA, and the measurement variable is only 1, which is crop yield. Then in scenario 2, we want to have a comparison between crop yield from different fields with 3 different amounts of fertilizers and 3 different types of soil. So because we have 2 types of the nominal variables, so we are going to apply two-way ANOVA. And what are these 2 nominal variables? Number 1 is the amount of fertilizer, and the other one is the type of soil, right? So these are the 2 predictor variables, or the 2 nominal variables. And there are 3 categories of the amount of fertilizer: 50 kilograms per hectare, 100 kilograms per hectare, and 200 kilograms per hectare. And we have 3 categories of soil: loamy soil, clay soil, and chalky soil, right? So we are going to apply two-way ANOVA in this case because there are 2 nominal variables. And the measurement variable is only 1, which is crop yield, and this is also our response variable. So I think the difference between the one-way ANOVA and the two-way ANOVA is clear.